number that starts with a number between 1 and 9 that is multiplied by a power of 10. So what that means is, for example, we have a big number and a small number here. We have a number between 1 and 10, or 1 and 9. I like to say 1 and 10 because it's going to be 9 point something, or 1 point something, or 2 point something, or 3 point something, like this example or this example. Multiplied by means times a power of 10. Some exponent that we're multiplying 10 times. So we're multiplying 10 times 10 times 10, for example, 6 times, or whatever exponent it says. So we use really, really big numbers and really, really small numbers. The big numbers always have a positive exponent because we're multiplying by 10 over and over and over again. So what we really have is 2.86, and if we multiplied this by 10 6 times, our number would get bigger and bigger and bigger. So we're moving our decimal to the right on our number line. I like to think of this as a number line. If 0 is here, 6 is a positive number, we're moving it to the right 6 times. We're multiplying by 10 6 times. So we went to the right 1, 2, 3, 4, 5, 6, and that's really where our decimal will end up. So every time we multiplied by 10, we added another 0. So our answer would be 2,860,000, just like it says there. We also can have really small numbers. We have the number 3 point nothing, so that's really where our decimal would be. But instead of multiplying by 10, we have a negative exponent, which really means we're dividing by 10. So if we're dividing by 10, we're really getting smaller, or we're moving to the left on our multiplication, or on our number line. We're dividing by 10 3 times. Dividing by 10 gets smaller, dividing by 10, dividing by 10. Our answer would be 0.003. So let's take a look at a few examples. On the left we have some numbers in standard form, which expanded is our just number written out. Scientific notation is our number between 1 and 10 times 10 to some exponent. If there's not a decimal in our number, you can always assume it's at the end. We have 450,000 point nothing. Okay? So we need to first figure out that number that's between 1 and 10. It starts with 1 point something, 2 point something. So think, where could we put this decimal? If we ignore all the zeros for a moment, we have 45. Well, that number's not between 1 and 10. So if I put the decimal between 4 and 5, we would have 4.5, which is a number between 1 and 10. So we have 4.5, but how many times would you need to multiply by 10 to get back to the original number? We would have to multiply by 10 1, 2, 3, 4, 5 times to get there. So we're multiplying by 10 5 times. So we moved our decimal 1, 2, 3, 4, 5 to the right. This is my answer that I'm looking for. 4.5 times 10 to the power of 5. Now we have a really small number. If I ignore all the zeros for a minute, I want a number between 1 and 10. Right now I have 631. That's not a number between 1 and 10, so I can't put the decimal there. That's not what I want. If I put it here, we'd have 63.1. I don't want that. So it needs to go between the 6 and the 3. This number right here would be 6.31. And now we need to think, how many times would we multiply, or really divide this, because it's a small number, how many times would we divide by 10 to get our decimal back to where it should go? So we'd be dividing by 10 1, 2, 3, 4, 5, 6, 7 times. So we move to the left on our number line. Remember here, positive numbers were to the right. To the left, we moved it a negative 7, or 7 to the left. That's why our exponent's a negative. Negative for small numbers because we're really dividing by 10. Next, another big number. If there's no decimal, we can assume it's at the end. But we need a number between 1 and 10, so if I ignore the zeros for right now, I have 631. Again, I would need 6.31 which is between 1 and 10. And now, how many spots do I need to multiply by 10 to get my decimal over to where it started? So we're going to multiply by 10 1, 2, 3, 4, 5, 6 times. Times 10 to the power of 6. Different numbers, but the same number out front. Just because it's the same number out front doesn't mean it's exactly the same number, because this one is really a small number, this one's really a big number. Negatives and positives tells us which way we're moving our decimal. This next one's a little tricky. Our decimal is right here to begin with. We need a number between 1 and 10. So if I ignore the zeros, 5 is in between 1 and 10, so it would be 5 point nothing, not 0.5. We don't want that. We want a number between 1 and 10. So we have 5. If you want to put point nothing, you can. And now how many times are we multiplying by 10, or really dividing by 10, because this is a really small number, 0.0005. We're going to divide by 10 1, 2, 3, 4, 5 times. We moved it to the left. Negative made it a small number. So -5. These next two I would like you to try, and then click play to see if you got them right. Alright, if there's no decimal, we assume it's at the end. So if we ignore the zeros for a moment, we have 145. We would want 1.45. That's between 1 and 10. And then how many times do we multiply by 10 to get this big number? Come on. We would need to multiply by 10. Our decimals here, 1, 2, 3, 4, 5, 6 times. So not times 6, times 10 to the power of 6. We would multiply 1.45 10 times, or 6 times by 10. Alright, this next one, it looks like a lot of zeros. I'm going to ignore them for a moment. We have 12. That is not between 1 and 10, but 1.2 would be. So how many times would I really need to move my decimal? I'd need to divide by 10. We're going to the left. Remember, it's negative on our number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times we moved our decimal. But we went to the left, so it's a -10. We were really dividing by 10 times. So originally we started with standard form and moved to scientific notation. Now we're just going to do the opposite. So we have the number 4.2. To work backwards, you're just going to start by writing the number 4.2. And then the exponent tells us how many times we're going to multiply or divide our number. 7 tells us it's a positive number. We're multiplying or moving to the right on our number line. Positive numbers are to the right. We're going to multiply by 10 7 times. So we're moving our decimal 1, 2, 3, 4, 5, 6, 7. And that's where our decimal is going to go. I'm going to slide this over a little bit. I should have written the number on the left side there. Anytime we multiplied by 10, we are really filling in each loop with a 0. Because multiplied by 10 times 10 times 10 times 10. Oopsies. So we moved 1, 2, 3, 4, 5, 6, 7 times. If you want to put the commas in there after every 3 numbers, you can. You would have 42 million. Alright, let's try the next one. We have 7. If there's no decimal, it's 7 point nothing. And this time we're moving, or we're dividing by 10 2 times. So it's a -2. We're really moving our decimal to the left, like on our number line to the left. 1, 2, that's where our decimal is now. We really divided by 10 twice, so we have 0.07. If you want to rewrite it, you can. Otherwise, it's fine just how it is. We're going to start by writing the number. And I know my decimal is going to be going to the left because it's a negative number, so I'm going to leave some space on this side. You don't need to write this word. So we have 4.398. We're moving our decimal 4 times. We're dividing by 10. 1, 2, 3, 4. And fill in each loop with a 0. Notice we moved 4 times, but we only added 3 zeros. So this number does not relate to how many zeros there are. It's close, but not quite. Just like here, we only added 1 0, but there was 2 numbers, or 2 spots to the left. Next, we're going to be multiplying by 10 8 times. It's a positive number. We're going to be moving our decimal to the right, so leave some space on the right-hand side. Don't write this, but leave some space over there, so we want to put the number over here, 3.484. And we're going to move our decimal 8 times. It's starting right here. We're not at the end. There's already a decimal there. We're multiplying 1, 2, 3, 4, 5, 6, 7, 8. And fill in all of our numbers with zeros. Oops. 0, 0, 0, 0, 0. Again, if you want to rewrite the number, you can. Otherwise, you can just put a big comma after every 3. You have 348,400,000. Next couple, I would like you to try and then click play to see if you get them right. So we're starting by writing the number 3, 3 point nothing, and I left some space on the right hand side because we're really multiplying by 10 5 times. We're moving our decimal 5 to the right. 1, 2, 3, 4, 5. That's where our new decimal is, and fill in our loops with zeros. So we really have the number 300,000. Last one, we have 4.1. I'm going to actually move this on the right side here because we're dividing by 10 9 times. It's a negative number. We're going to the left. We're making it smaller. We're dividing by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where our decimal is. Fill in all of our loops with zeros. Because each time we divided by 10, we have 0.00000, all those zeros for 1. That is our answer. So now that we know how to go between standard form and scientific notation, we are going to compare a couple numbers. It says to compare the exponent first. If they're the same, compare the decimal portion. So looking at our exponent first, right here, this one's multiplied by 10 19 times, and this one's only multiplied by 10 18 times. So since they're both multiplied over and over and over, even though these numbers are different, we're multiplying by 10 more times on the left. So alligator eats the bigger number here. This is the bigger number. So next, we have the same thing, but 5 and 5 are the same. So if they're multiplied by 10 the same amount of times, we need to look at the numbers. So which is larger, 9.4 or 7.4 or 2.1? Well, 9 is greater than 2, so alligator eats the bigger number. Next, we have a -3 and a -4. Be careful on this one. When we have negatives, we're dividing by 10 3 times and dividing by 10 4 times. So which one, if we have on our number line here 0, if we divide by 10 3 times, we would move our decimal 3 to the left. If we divide by 10 4 times, we'd be moving 4 to the left. So which one is really bigger or closer to the positive side would be the one that you went only -3 instead of -4. So this one is actually greater. It's towards the positives, closer to the positives. If you actually wanted to multiply them out, you could move your decimal 1, 2, 3. And this one would be moving 4 times 1, 2, 3, 4. So we can tell this one is less zeros in front. It's actually a bigger number. This one has more zeros in front. It's really, really small. Last one, we have a -10 exponents. They're divided by 10 times, each of them, so we need to compare our two numbers. Which is greater? We have 9.2 or 9.21. Well, 9.2 is really 9.2 and nothing, so the greater one would be 9.21. So alligator is on the right on this one.